Hey everyone, in this video we're going to start talking about ray diagrams for mirrors. This is one of my favorite sections. We get to actually draw things. So ray diagrams are just a way to visualize how images are formed. If you have a whole bunch of light rays coming from your object, they're reflecting from your mirror here, and they're forming that image where those points intersect. You don't really want to draw a whole bunch of rays to figure out where that image is going to be. So we're going to learn about 3 special rays that we can draw so that we can always find the image, find out exactly how big it is, exactly how far it is from the mirror. So here are the 3 special rays that I like to look at. The first one is going to be parallel to the axis and reflecting through the focal point. Notice that I'm talking about concave mirrors, so I'm using the bolded word here. So this is what we just saw in the previous videos from the definition of the focal point. That parallel ray will always reflect through the focal point. The second ray is going to pass through the focal point and then reflect parallel to the axis. Again, this comes straight from the definition of the focal point that we just saw. So you can see how useful the focal point is because it helps us draw 2 of our 3 special rays. The third ray that I like to draw is the one that goes through the center of curvature and reflects on itself. So if the focal point was right here, then we know that the focal point was half the distance of the center of curvature, so the center of curvature is here. So if you draw it through the center of curvature, it's going to reflect right back on itself. And that makes sense because if you think of this mirror as a circle, and it's hard to draw a circle, but if this is the center of it, then you know that when you're hitting that mirror, you're hitting it perpendicular to that surface, so you're going to come straight back in the same exact direction. So in general, you really only have to draw 2 rays, and wherever they intersect, that's where your image is going to be formed. But I always want to draw 3 rays because what if you make a mistake when you draw the first 2, and then where they intersect is not really where your image is? But if all 3 rays intersect at the same point, then you have a pretty good idea that you haven't made a mistake, because it's very unlikely for 3 rays to intersect at the same point if you haven't made a mistake. So what I have here are the same 3 rules that we just talked about, but for convex mirrors. So the only way that these rules are different is that for the first 2 rays, we're going to look at the second part that I have bolded here. So ray 1 is parallel to the axis, and instead of reflecting through the focal point, it's going to reflect from the focal point. So look at the picture so that it can make more sense. When you have a concave mirror, the focal point is in front of it. So it makes sense that if you have a parallel ray, that then it can reflect through that focal point. However, when you have a convex mirror, the focal point is behind it. Remember that if you trace that circle, right, that center is at the center of that circle, and that focal point is halfway through, half the distance. So the focal point has to be behind a convex mirror. So what that means is that if your rays are incoming from the left here, then there's no way that they can reflect through the focal point because the focal point's on the other side. So they reflect from the focal point. So that's my shorthand from saying they reflect as though they appear to come from the focal points, right? When you draw that parallel ray here, then it's as though the reflected ray comes from the focal points and goes that way. When you draw a parallel ray over here, the reflected ray comes as though there was a straight line from the focal point to the mirror there, and that's how you know the direction of the reflected ray. Same thing for ray number 2. Instead of passing through the focal point, it can't do that because the focal point's in the back. Your rays can never go through a mirror. They reflect from the mirror. So it's going to go toward the focal point, but then it's going to reflect parallel. So if we look at this ray over here, it's going toward in a straight line towards that focal point, but it can't go through. So as soon as it hits that mirror, it's going to reflect parallel. It takes a little bit of practice to draw these, but that is the rule number 2. So 1 and 2 is really the same rule as the previous one. It's just they don't go through the focal point, they appear to come from the focal point. Or they appear to go toward the focal point. Ray number 3 is the same as before. If you, and actually, I drew this incorrectly here because the center of curvature, I copied this from the previous slide, my bad, right? The center of curvature is on the other side, so it's okay to have a mistake every once in a while here. So if the center of curvature is here, then what this rule is saying is that if you have a ray that is going toward the center, let's say it's coming from over here, and going in a straight line here, so it's not a very good straight line here. All right, so if the ray is coming from over here, then it's going towards that center of curvature. It's going to reflect right back on itself. If you have a ray coming from over here toward that center of curvature, it's going to reflect right back in the same exact direction. So I should actually replace this to toward the center of curvature. Let's look at the rules for how we're going to draw a ray diagram. First thing you're going to do is draw that optical axis, that straight line that passes through the middle of your mirror, that horizontal line. Draw your mirror or your lens, and we're actually going to see that it's more useful to draw them straight and then just draw a little line to show me was that a concave or convex mirror. So if it's a concave mirror, I like to just go like this. If it's a convex mirror, you draw that straight line, but then you curve it this way. Your ray diagrams are going to be a lot more accurate if you have that flat surface, just the way that they're drawn. Draw the center of curvature and the focal point. Then you're going to draw so let's say the center of curvature is here, the focal point is here. Draw the object, wherever it is, use an upright arrow. Draw the 3 special rays emerging from the object. So we said that if it's parallel to the optical axis, it's going to reflect through. Now this is very rough, so it's not going to be very good. I'm just showing you the steps here. If it's going through the focal point, it's going to reflect parallel. And then if it's going through the center of curvature, it's going to reflect right back on itself. So extend the rays or trace them backwards until they converge. Well, they all converge at this point. Draw the image where the rays intersect. So the rays intersected right here, so you're going to draw the image right here. You always start it from the optical axis, and then you draw the arrow downward because the rays are intersecting down here.